Well, hi, and thanks for coming and joining me here in my shop for another day with this Giganto radio that has been very challenging and still is. So where am I at now? I'm pretty convinced that the local oscillator is not oscillating on the two highest frequency bands. So that's suggestive of a weakness in the radio, like a weak tube. That could be one thing, or it could be some capacitors in here that need to pass the signal and aren't doing enough of it at the higher frequency, or something of that sort. Who knows? I don't know. My plan here is to test the oscillator tube. Now, I did test all the tubes in the radio initially, but that was really about proving that they're operating, not necessarily proving they're in the best condition. Oscillator tube has to be in good shape to generate an oscillation, and the higher the frequency, the more difficult it is for the tube to do the job, or the circuit to do the job. So we'll test the oscillator tube first. I have a couple of spares of that tube too, but I don't know their condition. And then after that, assuming the tube problem is not really the problem, I'm going to use my scope to look at the output of the oscillator, go through the bands, just try to gather some more information, and then start thinking about what else could be causing a problem. So we're going to start off with the tube. That's this one down here. (6J7). Why do I think it's supposed to be a 6J5? Why would I think that? Just hang on one second while I just absolutely check this. 6J. (6J7). Yeah, 6J7. Okay, I don't know why I got 6J5 in my head, but I did. Now let's just spin around here. Okay, 6J7. J7 right there. 6.3 volts, 2 on the signal level, 31L, 17342, 27. One 17342, 17342. 610 0610 40 D for the plate. Grid cap goes on. There we go. So this tester is considered a dynamic tester, or one that can read the mutual conductance. So in this case, this tube should come up to 800 on here, which would be about here. So we get up over 800, it should be good. 800 is the rejection point. So looking for shorts. And then there. Okay, it's way over. So it's way over 800. There's no reason for us to suspect this tube is the cause of the problems. Kind of stroke that off your list, off my list anyway. Put this guy back in. So I'll carry on now, doing my plan here to use my oscilloscope. Let's move this over a little Okay, I'm going to stop and get things going here. Okay, so I need a spot to hook up my oscilloscope, so I'm going to try to hook it up on a low impedance circuit here. This is the mixer tubes getting the local oscillator on this grid here, grid number 3, through that capacitor. Probably my best hookup spot to try anyway is right here. It should be, I think that would be a low impedance, and hooking up the scope won't make any difference at all to it, but it might. So what we'll do is we'll go to we'll get on the broadcast band, we'll tune something in, maybe a signal generator or a station. Then I'll apply the scope at this point. We'll see if the local oscillator wanders off from the effect of the scope. Actually, you know what? I shouldn't be too concerned about that. Now, what I'm concerned about is, does it work or not? Not is it on frequency. Okay, but we'll once I hook this up, we'll be checking all the bands anyway, so that's going to take care of itself. The problem with this kind of test is that the test itself can stop the oscillator from oscillating. So, and how do you know that that's happening? It's not easy. So first, let's get the set operating here. Turn on my amp. Just for fun, we might as well have this on. 2. I think it'd be fun. Let's get the scoping properly over here. I hear activity at the door. There's a cat behind me. How are you today? Oh, okay. That sounded good. Now, back to what I'm doing here. Let's start up. Oh, coming right up to help out, are you? No, don't come around this side. This is not a good area to be. So this cat is not a lap cat. You can't hold this cat. You can't pick it up and hold it. You can't stick it on your lap. It just doesn't like that. Okay, we can put some low voltage on here and get things heating up. The scope connection is going to go on pin 8 of the oscillator tube. It's right up under here. I'm going to have to get you off my bench before we go too much further here. Unless you go over here and sit down. What if I made a little area for you? Okay, I make a little area. And you can go and sit down. Right here. How about that? Because you seem to like doing that. Okay, radio should be warmed up now. And we have a volume on the side. So the radio is actually connected to nothing. Antenna-wise, we'll leave it like that. Okay, now turn on some power, some voltage here. Excellent. Excellent. Now, I have no idea what band I'm on at the moment. So, but that suggests the local oscillator is operating on this band. Not sure. Let's hook up the scope. I'll make this insensitive first. Are you ready, cat? So, what? Grab on the yellow, not the yellow clip lead, but the yellow wire there. What happens? Not a good sign. Just seem to kill it dead. So we'll stick a resistor. What is this set to? It's set to ×1. Let's try the ×10 thing here. Very sensitive. So that's not going to work. I stick a big resistor there. Or a capacitor. I have a resistor capacitor combination here somewhere. Which I cannot find it. Here it is. I did find it. There it is. So we'll put this. Stick that in there. Well, didn't seem to have killed it entirely. Something came up on the scope there that time. But anyway. Stick there. Stick. I can't make it stick. But you could see that the oscillator was oscillating. You could hear it. Level dropped a lot though. So, you know, if it's a weak, this is gonna just take out whatever's left of it. That's too bad. Wrong spot. I gotta find a better spot. What would be a better spot than that? No, I could try the grid. I'm just assuming the grid is even more sensitive. That would be here. The grid on the 6J7 is what? What is the grid on the 6J7? I read in the book here what a 6J7 is intended for. It's not, they don't mention oscillator. 6J7. They just say amplifier. So the grid is on, oh, it's a grid cap. Grid cap, grid cap, grid cap. Okay, rotate. Hey. That's a little odd. Something's acting like a, there's no antenna connected to this radio. So you really don't know where that noise is getting into the radio. You assume it's coming in through the antenna. That's not necessarily the case. I can't imagine rotating the radio would act like it has a directional antenna on it. Oh, small things for small minds. Let's get this out of here. This is the antenna for my SDR. We're not using it right now. And grid cap, grid cap, grid cap. Right. Grid cap. Now, this is the, what they said was if you can move the grid lead wire a little bit, it will change things. So sound of a gun. It's still there. Oh, can't hear it, but I can see it on the scope. Okay, let's run with that. Let me put this here. Okay, times 1 kills it. Times 10 leaves a little. That's what this resistor. It's not a very big resistor. It's like an 80 ohm. It's really small. Flip it on there. Well, it's a start. It's a start. So there's the oscillator oscillating away on this band. Now I've got to turn this. I got to reach the band. Oh my gosh! How am I going to get to the band switch here? A bit of a logistics error. So I've got to put a tool on it to get at it. How far can I rotate? Okay, that's far enough. Band switch, big tool here. Now we're going to want to watch the scope. All we're hoping is that something similar to what you see there will come up. Let's see. I don't know what band I'm on, so I'm going to rotate all the way to the broadcast band, which is where I think it is. But let's find out. So that's broadcast. See how big the oscillator is? Broadcast. 49 meter. 31 meter. Did it go away? I think it went away. 25, and so nothing up on these two higher bands. So we got a strong oscillator with my, let's go here. Now there's no oscillator running here, so the radio should have not much sound to it. And when I disconnect it, if the oscillator comes to life, we may be able to tell just from the change. That would prove I'm killing the oscillator with this connection. Grab the volume. Let's just turn the volume down just in case a surprise is coming. Okay. Scope off. Come on. There we go. Scope off. Volume up. Doesn't sound any different to me. Didn't I find only 2 bands not working? Now it appears 3 are not working. So this technique of using the oscilloscope, it certainly has problems. Is this radio dying as I go? Did taking the tube out and putting it back in somehow knock off another band? Is it just, it can't be that stupid grid wire. It can't be. Can't imagine that. It's not shorting, is it? They were, so I had not replaced the grid wires, and they have the potential to short where they come through. Just make sure that's not the case. Wow. Oh, so this is the grid wire I'd be concerned about for the oscillator, and it's actually got a grommet in the hole. The other grid wires are not grommeted in their holes. You put a grommet in the hole to fix the position of the wire relative to the chassis, because if the wire moved in the hole a little bit, and it can move from the center over to the edge, that is probably exactly what was going on with these radios that I read the service bulletin, and they probably fixed it. They probably found out in the end it's right here where the wire passes close to the chassis, so they grommeted it to hold it. That's my story. That's my story. But the other ones aren't important, so don't waste a grommet on those, because you know, grommet, quarter of a penny a piece. That adds up, you know. So I think what I'm left with now is once again utilizing the SDR and accepting the result by doing a more thorough sniffing of the signal. You know, I did a pretty good job with it the first time around. I think I have some trouble believing that. So I just want some proof here. What happened? Here it comes. What the heck is going on? There we go. Just caught on stuff. So SDR is just another, it's not just another, it's a really cool kind of radio, nothing like this whatsoever. It uses computer software to process the signals and produce, you know, to detect the radio signals. Excuse me. So let me pop it up. I'll get it up on the screen here. Okay, let's get it going. Let me just check something here. Direct sampling Q branch is correct. Now, since I did this once before, I don't really expect much different. Let's start right with the broadcast band. Okay, broadcast band. So we'll slide this. Broadcast band. So this is the broadcast band. You can see lots of noise being picked up by my by that. I put my hand on it. Didn't make much difference, did it? But you can see a little difference anyway. Just kind of prove things out. Now I'm going to wave this at the back of the radio. These are the oscillator coils here. So right away you see the radio's output sound changed a bit because I'm affecting the coil for it. And you can see on the SDR, you can see a white line going up and a red line coming down, kind of dotted. That's the powerful local oscillator on this band, and the frequency it's showing is it would be close to 1360. So if you subtract 460 from 1360, you get 900, and the radio is tuned to 900 on here. Perfect. Next band. Next band is 49 meter band. We saw the local oscillator. Let me turn it down the sound. We saw the local oscillator. 49 meter band is 6 megahertz area. There it is there. We see something very strong over here. I'm going to tune the radio, and if that moves, yes it does. Now I'm going to tune the radio up frequency, and it should move up frequency. So there's the local oscillator. What is doing down there? Once again, let's just verify this. So the oscillator's at 5600. The radio should be trying to tune 6 million 60, just above 6 million. We look at it, 6 million 60. Right, it's exactly right. But that's because in this case we're accepting the idea that the local oscillator is running below the target frequency, and I don't think that's normal. It's usually above, but is there any usual here? Now we'll go to the next band. Just goes silent. 31 meter band. 31 meter band is 9 right in here. A pretty strong signal right here. And I got something strong in here too. But again, it's gonna, if it's the oscillator, oh, I haven't even got the antenna held up there. Okay, let's put the antenna up. Well, there sure looks like an oscillator sitting there, right around 10. Okay, so what's happening is I move the coil around, I'm affecting the frequency of the coil I'm checking. So it's kind of jumping around a bit, but that's okay. I can hang it here, hang it somewhere, hang it right there. Now, that should move when I tune the radio. There it is. I'm going up, it's going up. See, there's something on the left side. Who knows what that is? We'll just ignore it. We'll set this to 10. The local oscillator is now at 10. So if the local oscillator is supposed to be below, like the other band, then this is misaligned. If it's supposed to be above, it would be in the right place for the frequency of 9540. 9540, I think. 9540 sounds about right. And what do we actually have? We're on this band, 95, almost 40. There's 40, almost there. So the local oscillator, it's 460 away from the target frequency, but it may be above when it should be below. I think this comes back to why they were talking about 2 peaks. If you find 2 peaks, you got to pick the right one. Otherwise, you're aligning the radio on the image, and that's not going to work out all that well. Okay, so 3 bands apparently working somehow. I have to make a note here. Below on the 49, above on the 31. Now we'll go to the 25 meter band. Let me just check. There should be dead end here. Yep, one back. Okay, we're now on 25 meter band. That's 11 megacycles. Hey, what's that thing doing there? Let me just tune this a little bit. No, it's nothing. It's just a thing in my shop. So I'll go up to 11 here. So see, I don't see anything. With the radio tuned where it is, roughly 11,800, you should see something if it's above at 12.2. That's here. And if it's below, it would be 11.4. Oops, sorry, 11.4, which is just around here. Nothing there. I wonder if I tune to one of the extremes. Let's say I tune to the low frequency extreme if it would start showing up. Fat chance on that, because the low frequency is not much different than the high frequency on these spread bands. So I can't imagine that's going to do anything. There's just nothing available, nothing visible rather on there at all. Okay, so I'm verifying the results from yesterday. Might as well do the top band, but I can't imagine that somehow suddenly it's going to work. 15 megacycles. Just want to make sure I'm chasing a real problem and I've got the parameters of the problem correct. I don't see anything here. So we are currently tuned to 15,250, so this should be at 15.7, which is here, or it would be 15,250, 14.8, somewhere in that area. That's also on here. There is this thing sitting over here. Okay, I'm going to tune the radio. Is there anything? Is it move? Anything moving? Nothing moving. So I don't think there's any local oscillator here. So I am really encouraged now to really hunker down and try to figure out what is it that has happened. Is it possible that the radio is simply aligned so poorly that the oscillator can't trigger? I can't believe that. The alignment slugs don't look to be wild. They're not all the way in or sticking out the back of the radio or anything. There's something more than that. So there's no oscillation at all. That means the oscillatory circuit itself is not operating. It's not that it's not making it to the grid. It's that it's not there at all. If it was there at all, I would find it with this coil. So the actual oscillatory circuit itself is not oscillating. So we need to look again, so I kind of did a little bit of this, look at the schematic and try to figure out what it is these two bands have in common, since the oscillator seemed reasonably strong on the 31. So I would think if you're going up in frequency and the thing is weakening to the point where it can't run, that the last band running would appear weak. Just thinking about, I have this radio operating. I'm going to forget it's operating. That's what I'm worried about. It's so quiet. Yeah, silly debate. Should I turn it off? We'll leave it on. Look at the schematic here some more. I got to come up with some kind of theory now. So what I'm thinking now is something within the oscillatory circuit is weakening the situation, and so I'm looking first for a capacitor through which all the signals pass all the time. I see one right here, C12. It's right on the grid here. So, if the capacity of this is gone, or something's wrong with it, the signal getting through would be weakened. Very hard to test this kind of stuff. You put a scope on here and on here, you're just affecting the circuit so much, you're just seeing your own effect. So that could be a bad guy there, I think. Now, where else? We follow the oscillatory circuit here. So come up to plate. There's the feedback transformer shooting the signal back into these coils. Incidentally, check this out. So we know broadcast is working, it uses this. And we know 49 meters is working, it uses this. And we know 31 meters, hey, 31 meters uses this capacitor. These coils only come in to play on the top 3 bands, but wait a minute, but this one's working. This band's working, so okay, man, we got a little excited over nothing there. I thought I discovered that all 3 of these coils were not responding, but one of them is. 2 of them aren't. Okay, so let's carry on, follow this through here, down through here. The resistor here, just ahead of this. So I don't think this resistor would play a role in weakening the oscillations. What's going on here? Here we're giving probably a DC. This is probably, oh my gosh, I'm gonna go all the way back here. ABC? Out of here? I don't think so. It's out of here somewhere. It's over here. So this is ABC. Never mind. Never mind that. Well, I don't know. You know, my first guess would be this guy. That's a guess. Absolute guess. C12 may be hard or easy to get to. Now, is that the entire oscillatory circuit inside here? So we do have this guy here who should be out of the picture because I have this switch closed here. Do I really have that switch closed? And I think I worked it and it didn't do anything anyway. Yes, the switch is closed, so a ground is applied, apparently doing away with the influence of this tube, which is the AFC tube, if I can call it that. Here's another one. So the oscillation, wait a minute, no, this may not be what I thought it was. The oscillations are traveling in here, all down through here, through here. So maybe here's another one that everything goes through. But you know what, when you change bands, so you get off the broadcast band, this capacitor's out of the picture. So we're really back to this one. I better find this capacitor, C12. C12. Okay, well let's look at the diagram down here. Show us where it is. Show us where C12 is. Okay, so we'll get to the oscillator 2. Maybe it's around there. C13. It's going to be not that kind of capacitor. C. I just rotated the image here. C. C12 right there. See, it looks like one of these special looking capacitors that are in this radio. They look like the kind of thing I shouldn't fool with. Maybe, so what I was thinking was if you have a capacitor here that can't pass a signal, then you measure the signal high on one side and low on the other. Inappropriately low on the other. The problem is as soon as you put your, again, test equipment on this stuff, it's a whole new ball game. Well, I can easily replace it. 110 picofarads. Let's take a look at where it is, because it's kind of out in the clear here. Fairly easy to find. Okay, so it's probably this one right here. And the radio's on. See, I forgot. Let me just kill the high voltage here before I get myself really excited. It says 5A, 3A, 1A, 2A, 4A. So these capacitors are numbered. 1, 2, 3, 4, and 5. 1, 2, 3, 4. 1. Yeah, 5 right here. Looks like a 0. That's kind of interesting. 1A. I don't know, are there more like that? Wow, I'm just looking up in the image on my TV screen. Well, it looks like it's as bright as day in here. It is not. I'm working in the dark. Working in the dark, but I don't see any more of those. So what's going on here? That they have these very special looking capacitors here. They could be frequency compensating capacitors. I don't know. And they use them all right here. I don't know, maybe the radio is so dependent upon these capacitors being precise and accurate that the manufacturer really went out of his way to get something really great. Spent a lot of money on those guys. They're clear. You can actually see the structure inside the capacitor. The chances of these being a problem is really low. What's that? I think these are resistors, believe it or not. Let's just take a look and see what is that. Okay, so we have the capacitor, and then there should be a thing tied to the metal plate here. So that means that's a connection. Oh boy. Might, it's not so easily seen on this diagram. Oh wait, there's something wait a minute, something right across here. That's probably it, because there's nothing else there. You see 1, 2, 3, 4 of those capacitors, kind of looking downwards, kinda. There's also a terminal strip standing out. It's really hard to tell in this diagram, but I think it's right there. I think that's the connection to this, and then this is going to ground, something similar over here. That doesn't look quite right, does it? What's going on in there? So that's probably it. And what is it? 3300. It's a resistor. Very unusual. So these are also probably very special resistors that have some desirable characteristic, and they paid a little more money to put them in the radio here, jack up the price of the radio. They could be temperature compensating resistors. I doubt it very, very, very much, but there's something special about them because they're unusual looking. And the value is 3300. So if I do body and dot on that, I get orange, orange, and orange. Yeah, orange, orange, orange is 3300. There is, yeah. And then on next to it, there's 3300 also. I'm not finding anything here that's really pursuable. We can measure this resistance and see what we get. So really, I'm gonna turn off the heaters also. I'm not getting a good feeling about this at all. $33K. Pretty darn close. This guy looks the same up here. I think it said the same on the gone a little high. There's nothing I can do with this capacitor really. How do I try to measure it? It's crazy. Band switch, band switch, band switch, band switch. Do I know for sure the band switch is not causing this? Do I know for sure? I don't. That's something I can check into. I made a half-assed attempt at, cleaning them. Switch is right here. This is the oscillator switch. To get in there with a better camera and get a much closer look. I can't imagine I'm going to see anything, but I really don't know what else to do at this point, so let's try it out. Okay, let's try this now. I'll take a good look at the switch up here. Anything going on with it? Well, it's pretty darn dirty. Nothing up here is broken. That's one side. Now the other side. I don't know if I've ever really come across a broken switch. They're really quite surprising. They just guess the little spring clips could maybe get bent upward somehow. It's gonna come up this way. Haven't got enough hands. Let me tighten the focus here just a little more. There you can see right inside these clear capacitors. And this is the first side of the switch here we looked at already. Lots of looks like corrosion building up in the where they bent over those clampy tangs. Lots of chemistry going on the surface of these metals here. So I have to watch the switch operate here and make sure that the clips are moving up and down, making contact. So let me just, I've got this turned off, which is good. Okay, now watching the action. So what I'm watching as I wiggle, as I turn the plate, I'm watching the fingers to see if there's movement in them, indicating contact. And I would say yes. You can't make, that's the end of the road there. Let's go the other way here. Now that finger should have dropped. Yeah, a little bit. But that other finger back there, that looks kind of out of contact. I don't think it's making contact. Oh, maybe. flimsy. And then that last one picks up the larger tang part. So this would be broadcast. This is working. This band's working. This band's working. And this band's not. So I don't anything at all to do with this. You can see where the contacts take place. The metal actually stays clean because, of course, it's being scraped. Okay, let's look at the other side of this switch here and rotate it and see what it does. Okay, so you can see that clip go up and down. Next one's going up and down. Now look at the top, like the far left. See the clip's going up and down. That's going up and down. And so, okay, so this is good band, good band, good band, bad band. Going back one, good, bad, bad. And that's the end of the road. That's all she wrote right there. Every contact seems to be moving properly. Lots of dirt. Possible, there's just so much dirt, it just never ever made contact once. So to ameliorate the situation, I'm going to get my good old can of WD-40 here. Where are you? Oh, someone's here. It is. Here it is. Let me see. Someone snuck off with my can of WD-40. So WD-40, it's not alcohol, of course. It's it's a light oil with solvents. So it has a little more. It has some solvent capability. And I found it extremely effective in these kinds of deals. Oof. I think I sprayed a little bit here and there. I give this zero chance of working. Okay. So now we're left on the top band, 19 meter band, which isn't supposedly working. Put a little coil here again. Is there anything else I did to this radio in the meantime? I don't think so. Turn the volume down. Okay, heating up the tubes. We'll give it a little bit of voltage here. We're on a silent band. Still silent. Volume's up. Volume is full. We need to go to a band that works. I have to go 1, 2 to get to 1. Volume down. 1, 2. You hear that? Barely. Okay, now make sure this is operating on this band, which is the 31 meter band. Let's go back and take a look at the SDR. 31 meter band is 31 meters. Ooh. Was a working band. This was a working band. Right. Okay, so I'm going to move the local oscillator, and there it is moving. Okay, now go to the next dead band. Did the band. Okay. Still making the same sound out of the speaker here. Let's see. Pretty quiet. 11. Okay, just double checking everything, done everything right. We are on the 25 meter band. 25 meter band is 11 megahertz. That's correct. I'm being like a pilot on an airplane here and just going over the checklist. So wait a minute, wasn't there something here a moment ago? Well, there's nothing there. And working the band switch. I mean, this would give it away if it shows up while I'm doing this. So I switched bands. Oh, the rabbit hole. I can see the rabbit hole. It's right there. Have I done something wrong here? Well, yeah. Let me tune the radio. Son of a gun. You know, when I scoped the local oscillator, I couldn't tell what frequency it was. Didn't bother with that. I could have seen this way up here. Oh man, what is happening here? See, that doesn't make much sense at all as a local oscillator. If it's oscillating at 12.2, it's trying to tune in 11.8. Okay, let me just correct my brain here. So I'm going to make sure I'm on the band I think I'm on by going all the way to the end. Okay, that's the end of the run. That's 19 meters, 25 meters, 31 meters, and up comes a thing. At 31 meters, oh my God, I have to just doubt myself at every turn. It's 9 megahertz band. And here's something like an oscillator running up here. What's going on down yonder? Yeah, big one here. This is the real one. The fake oscillations coming out of the local oscillator. That's not good. You know, more oscillations and more things are going to get tuned in. Oh my God, can this really be happening like this? Ho ho ho. You know, it could be a radio has this kind of stuff in it. Oscillations in the oscillator far away from the target frequency, where the radio is so insensitive that if it manages to produce, you know, a 455 product or 460 product on this radio, it doesn't really matter, because the incoming signal from the antenna has been weakened so much by the front end tuning. The spurious signal doesn't matter. I don't think that's the case. I think normally the oscillators in these radios are oscillating at one frequency only. Oh my gosh. So I'm exactly where I was when I started. 2 bands, no local oscillator. 1 band has, well, all the local oscillators have gone on to 1 band. I just have to move them back to the right band. Wow. Just trying to reassure myself here by tuning the radio. It's also this SDR sometimes shows ghostly signals that I don't think are really there. Yeah, I gotta stop and think now, because I'm really at a kind of a dead end here on what the smart thing to do next is. Of course, you know, not knowing the smart thing, that's maybe a standard operating condition for me. I gotta stop and think for a bit. So I think a reasonable question at this point is, are these coils open? So to find that out, what I can do is, let's see, it's chassis ground on one side. There's the capacitor and resistor. I know where these are. So if I read the resistance from here, to the chassis. I could switch through these coils, 1, 2, 3 coils, and then a capacitor. And I should read the coil resistance, which I think is written right there. And I'm sure it's point something ohms. Something really tiny in here. So this one I think says 2 ohms for this guy, but we'll just be testing these 3, I think. Okay, got the voltmeter hooked up, or ohmmeter rather. It's already giving a measurement. That's not point something, that's 1 point something, but let me just switch the band switch here. Okay, so we're starting at the top band, which is not working, 19 meter band. We get 1.4 ohms. Next setting, it didn't change at all, did it? Next setting, curious there, it's exactly the same. Next setting, this should be 0. This should be open circuit rather, because I believe I'm reading through a capacitor now. And that one's open. We've reached the broadcast band, and I think things have changed enough that I'm not surprised to see an open. This is surprising though. This should be open. And then these 3 all reading exactly the same. There must be something wrong with what I did in this test. Let's look at what I've done here. So I've clipped my voltmeter on this red clip onto this capacitor on the switch side. The switch side of this capacitor. The other way is a resistor to the chassis and a wire going up to the grid. So we'll look at this capacitor again on the circuit diagram and just see. So I'm on the non-resistor side, or the switch side of this capacitor. Non-resistor side or switch side. Not on the grid side. Okay, let's take a look. So this is the capacitor I'm looking at. Is that really the right capacitor? $110, I believe it is. C12. So and then there's the resistor, which I saw, 33. And I'm on the switch side. So this side, that's correct. And this side is a grid wire. Perfect. Yeah. So I've clipped here with my own meter. I'm reading through this thing, which I don't know what it is yet. I think it's maybe I'm not sure what this is. You could say, well, it's the same as these things. But these things have a number, C8, and a value. Something, I can't read it. 8, 6, and then here's C7 for this. This guy has no label. And nothing there at all. Yet he's drawn it with the circle here, which maybe was a mistake. Because maybe it should have been drawn like this. No circle. Oh man, you try to troubleshoot everything, including the information you get. And believe me, I have more than once encountered quite wrong information in these kinds of things. I don't think that's the case here. No reason to think that yet. So I clipped on here, and then I'm measuring through here, and then into the coil of choice. This switch has been advanced so that the contactor here is all the way up here to start. This is the 19 meter band. So I'd be reading from here through the link, through the closed switch here, through this coil and into the ground, and there's the resistance again. It really looks like 0.09 or something like that. It really does look, and it's just a tiny bit of wire. I mean, this is almost impossible resistance to read, but when I do this I get 1.4 ohms. How can you get 1.4 ohms? How can you possibly get 1.4 ohms? So, not this way. 1.4 ohms, where can you come into the picture? So conceivably, this when I started is not connected, it's way up here. In fact, when I move this all the way down to this position, this is the broadcast band, then I get an open circuit. So let's trace that. So open circuit. How do you see an open circuit? Right there. you run into a capacitor. Oddly enough though, I think I should get an open circuit here. But I don't. I get the same 1.4. I get the same 1.4 all the way through here, including here. Where would that come from? That's 0 in my meter. My clip leads are doing it. Maybe it's a meter. Maybe it's a reading problem. Let's go. Let's check that. Maybe it's just, I got these clip leads in here. Let's start by taking the clip lead here and clipping it to the chassis and seeing if we get a 0. Aha! No 0 coming. So I'm reading this chassis connection against this chassis connection and getting 1.4 on my meter. See if it's a clip lead. That's even worse. Let's go on here. I'll go on some socket here. A little closer. If I get this clip lead out of the circuit. No clip leads. No clip leads. Just read between, well, 0.2. 0.2. And I'm going to do it with this. So I'll hold these on. So finding a ground up here, out of sight of the camera. We'll check it. 0.2. Some trouble knowing what band I'm on. Let's put it on the high band again. And that's where it is. Okay, it's on a 19 meter band, a problem band. We're expecting a reading of less than 1 ohm, so we're starting not from 0 but from 0.3, so 0.2, 0.3, 0.1. Somewhere down in that area. It's very difficult doing these low resistance measurements. So we want to go to a ground point. I'm trying to pick a real good one here. Ground point, and then we're reading from here. 3.2. So it's a virtual 0. And I think that, really for what these resistances are just a little too low. What we're looking for is an open circuit anyway. An open coil. I already tested these coils. I don't know if I did it on camera by actually reading on the terminals here. What are the chances you'd have 2 of them open? Look at a big wire. Big wire. Stuck. Stuck. Still stuck.